Okay, today we are going to be moving on to Learning Target 2 from Unit 5, which is I can verify similarity through a sequence of transformations, including dilations. So previously we had talked about the different transformations, which included translation, which was sliding a figure across the coordinate grid, reflection, which was flipping a figure over a line of reflection, and rotation, which is turning a figure around a center of rotation or a point of rotation. With all of those transformations, every single time that we transformed a pre-image, we got a congruent figure as our image. Now we're going to be looking at dilations, which that will not be the case. It's a different kind of transformation because it will not keep your pre-image the same size as the original. So a dilation is a transformation that enlarges or reduces the size of a figure. So because of that, our transformation can no longer create a congruent figure. Instead, a dilation creates what we would call similar figures. And similar figures are similar in the sense that they have the same size angles and their sides are proportional. However, the size of the image is going to be either bigger or smaller than the original. So in order to dilate a figure, we need to know or find a scale factor. And a scale factor is the ratio of length of a side on a scale model to the side of the original object. So if we're dilating a figure and we have a scale factor that is greater than 1, that is going to enlarge the pre-image. We would consider that an enlargement. If we have a scale factor that is less than 1 but greater than 0, so a fraction, that is going to reduce your pre-image or create a reduction. So how do we do this? So our first example here says dilate triangle ABC by a scale factor of 1/2 with the origin as the center. Okay, so since the origin is our center, we can create a dilation notation, which when we talked about translation, we had translation notation where we were either adding or subtracting to the x and y coordinate to slide our figure up or down or right or left. Whereas with dilation, we're going to be using multiplication. So if I'm dilating by a scale factor of 1/2, I would do 1/2 times my x value and 1/2 times my y value. Those should be the exact same in your dilation notation. So if I look at my pre-image triangle ABC, I see that my pre-image A point is at 2, 1. My pre-image B is at 2, 5. And my pre-image C is at 5, 1. So if I take each of those points and multiply each value by half, my image of A, 2 times 1/2 is going to be 1, and 1 times 1/2 is going to be half. 2 times 1/2 is 1, 5 times 1/2 is 2.5, or 2.5. And then C, 5 times half would be 2.5, and 1 times half would be half. So then I can graph that. So my image of A is at 1/2. So 1/2, so right about there. And remember, when you are labeling, You're using your tick marks to show that it is the image of your original figure. B is at 1, 2.5. 1, 2.5. And again, use our tick marks. And then C is at 2.5, half. So that would be our image of C. And we can see that we dilated our pre-image, and since our scale factor was less than 1, we should visibly be able to see that it is smaller. Now, if we look at our second part of this question, it says to dilate triangle ABC by a scale factor of 2 with the origin as its center. So if the scale factor is 2, this is going to be an enlargement. So I'm going to take that scale factor and multiply it by my x-coordinate and my y-coordinate. And that is my dilation notation. 2 times x and 2 times y. Now I'm going to start with my pre-image points again, so 2, 1, 2, 5, and 5, 1. Let me change colors here. Okay, and so if I'm dilating my pre-image A, 2 times 2 is 4, 1 times 2 is 2. 2 times 2 is 4, 5 times 2 is 10, 5 times 2 is 10, and 1 times 2 is 2. So then I can graph this. So go to 4, 2. And we have my image of A, my second image of A there. B is at 4, 10. And my image of C is at 10, 2, 1, 2, 10, and 2. And then I can connect. And again, I can very clearly see that my pre-image was enlarged, which makes sense because my scale factor is greater than 1. So looking at example 1 here, we have a triangle with vertices at 0, 0, 8, 0, and 3, negative 2. We want to find the coordinates of the triangle after a dilation with a scale factor of 4. So since my scale factor is 4, if I write my dilation notation, I'm going to take my x and my y coordinate, and I'm going to be multiplying both by 4. So if I look at 0, 0, 4 times 0, we know is 0. And 4 times 0 is also going to be 0. So when I dilate the origin, it stays the exact same. Point B, if I have 8 times 4, or 4 times 8, that's going to give me 32. And then 4 times 0 again will give me 0. And my last point, looks like it got cut off a little bit here. If I have 4 times 3, that would give me 12. And then 4 times negative 2, that would give me negative 8. So I have my image of C is at 12, negative 8. So when you're given the scale factor, you're able to just apply it to those ordered pairs or side lengths. However, we are not always given the scale factor, and we may need to find it. So in order to find the scale factor, you're going to use the following ratio, where you're going to take the dilated image side length, and you are going to divide by the original side length. So you'll hear me say in class often, dilated over original, dilated over original. So if we look at example 2 here, it says, through a microscope, the image of a grain of sand with a 1/4 millimeter diameter appears to have a diameter of 11 1/4 millimeters. What is the scale factor of the dilation? Okay, so if we're talking about a grain of sand is incredibly small. And so we are able to see that the original size of that grain of sand is 1/4 of a millimeter in its diameter. Yet when we put it under a microscope, it appears to have a diameter of 11 1/4 millimeters. So if I'm looking for my scale factor, I am going, well, first and foremost, I can even ask myself, is this going to be an enlargement or a reduction? So going from a grain of sand, putting it under a microscope, what does a microscope do? It enlarges it. So this should be an enlargement, which means that my scale factor has to be greater than 1. You should always be asking yourself if it's an enlargement or reduction, and then if it's an enlargement, what does that mean for the scale factor? If it's a reduction, what does that mean for the scale factor? Because that's a really good way to check if your math is correct when you put the ratio together. So if I set up my ratio of my dilated value over my original value, and I do 11.25 divided by 0.25, that gives me 45. So my scale factor is 45. So the image is 45 times the size of the original diameter. Which makes sense because, again, we had already told ourselves we were looking for an enlargement and the scale factor has to be greater than 1. So 45 definitely makes sense there. So example 3, determine whether the dilation from A to B is an enlargement or a reduction, then find the scale factor of the dilation. So if we are looking from A, figure A, which is our triangle to the left here, to triangle B, again, we should be able to tell that B definitely has gotten bigger from A, so this would be an enlargement. So in order to find whether or not, or what the scale factor is, we need to take our dilated side length and divide it by our original side length. So we can take our base side length here, and in A, that is 3 units across, and in B, that is 6 units across. So if I take my dilated value and divide by my original value, 6 divided by 3 is equal to 2. Now, we can do a second side as well, and we can find our distance from the top of A to the base of A using our Pythagorean theorem. So if I see that one leg of my triangle here would be about 1.5, one other leg of my triangle would be 3. So if I do 1.5 squared plus 3 squared, that would be, let's see, 1.5 squared is 2.25 plus 9 equals 11.25. Take the square root of that, that's approximately 3.35. If I compare that to my dilated image with B, I have a leg of 3 and then a leg of 6. So that would give me 3 squared plus 6 squared equals c squared. So 9 plus 36 equals 45. Take the square root, that is approximately 6.70. So if I set up that ratio again of my dilated side length over my original side length, if I divide that, 6.70 divided by 3.35, we also get 2. So my scale factor is going to be equal to 2, which makes sense, again, because we've already identified that it's an enlargement and my scale factor is greater than 1. So my dilation notation, if I take 2 and I multiply it by x, and then 2 multiply it by y. Okay, so I would like you to continue to practice on your own with the dilation practice that is attached, and we will check it tomorrow. Thank you.